Today we're talking about muscle, why it's a key to longevity, and maybe most interesting to all of you, what can you do to build and sustain healthy muscle across the lifespan? So there's two parts of this. Why is muscle so important beyond just looking good in a bathing suit? And then what do we do to build healthy muscle and to protect that healthy muscle over the course of our lifespans? As I'll be discussing, we tend to lose muscle as we age. And this is a really big concern, not just because it makes it harder for us to get out of a chair or fall or otherwise have issues with our kind of physical function, but because muscle does a number of important things beyond just structural benefits for our bodies, things that relate to the immune system, to longevity, and to metabolism. One thing I'll say is if you're not watching this live, or if you are watching this live, there will be a replay. We'll send this out. So if you're tuning in, you will get access to this later. Okay. So general disclaimer here is that these are not statements that have been evaluated by the FDA. This is not me providing you with medical advice as a doctor. This is just general information. So where I'd like to start this conversation is this question of what is muscle? And so many of you have your ideas of what muscle is. We see a person, we say that is a muscular person because they have a lot of muscle, or maybe we can just see their muscles. But muscle is such an interesting and nuanced field of science because each of us has in our bodies over 600 different muscles. Your muscles are connected to your bones by tendons. And they're actually the primary source of what your body uses to generate heat. So, meaning when you exercise and you start feeling warm, that is a reflection of what is happening in your muscle tissue. There are three major types of muscles. And for those who have taken anatomy, you'll have this be a quick refresher. You have smooth muscles, and smooth muscles we really don't have much control over. And these are muscles found in places like your gut and your blood vessels. Then you have striated muscles. And striated muscles, as we'll discuss in a moment, are so defined because they have these repeating units called sarcomeres within it. So they actually look striated, they have lines. There are two different types of striated muscles. There's cardiac striated muscle. And so cardiac striated muscle is found in our heart. And then we have skeletal muscles. Skeletal muscles are often called voluntary muscles because unlike smooth muscles, they are under our conscious control. I do think that there's a little bit of an interesting nuance here because for anybody who's ever done biofeedback, you recognize that you can, in some ways, influence the function of certainly your heart muscle because you can stress yourself out and then make your heart muscle pump more quickly, or you can calm yourself down and make your heart muscle function more slowly. But also, we're learning that some of the things that we do through, again, biofeedback, meditation, relaxation, can have effects on the muscles, even in our smooth muscles, so in our gut and our blood vessels. But really, skeletal muscle is the voluntary muscle in that we can choose actively how much we want it to contract. So right now, if I was to reach out and pick up a book, I would be using my skeletal muscle to make that happen. So it's under voluntary control. So as I alluded to, skeletal muscle is made up of these repeating units called sarcomeres. And so skeletal muscle is made of these fibrous strands that interlock into these sarcomeres. These are really the functional unit of striated muscles. And sarcomeres are made of these protein filaments that pull and contract in order for us to be able to do things like lift a book or get out of bed. This is a really key building block. The importance for all of you is not necessarily to understand what you can do to necessarily influence the sarcomere, but as we'll discuss in a moment, the kind of core issue with muscle function as we age is called sarcopenia, because it is actually a lack of healthy sarcomeres and muscle tissue. So again, sarcomeres are the functional building block of our skeletal muscle. As I've said, skeletal muscles are voluntary, but some interesting facts around your skeletal muscles is that roughly up to 40% of your weight is going to be made up of skeletal muscle. So it really is the largest tissue in your body. Like anything in health, we think about, well, we want to have the biggest bang for our buck with our interventions. And if you realize that 40% of your weight is made up of skeletal muscle, and as we'll talk about in a moment, Our skeletal muscle health is something that we can hugely influence through lifestyle choice. We realize that by impacting skeletal muscle, we get a lot of bang for our buck in a way that we can really benefit our long-term and short-term health. Also, it's important to note that skeletal muscle makes up around 75% of the total protein content in your body. So this is the reservoir of protein in your body. And as we'll discuss later when we talk about nutrition, this is one of the reasons why protein is so essential to healthy skeletal muscle because it is really made up of all of these proteins. Another thing to consider around skeletal muscle is that it is incredibly responsive to the demands that are placed on it. And that can be for the better or for the worse. So, this is what weightlifters are trying to do. They're trying to hypertrophy, they're trying to grow their skeletal muscle. If we don't use our skeletal muscle, our body says, hey, I don't want to be wasting all of these resources to keep these big muscles that are doing nothing for me. And so the flip side of hypertrophy is atrophy. Again, our bodies are really smart. They have the ability to adapt based on resource availability, based on what's happening in our environment. So if our skeletal muscles are getting a signal, which is, hey, we actually need to be strong and have these muscles to function, they're going to build up. But if they're getting the signal that there's really not much going on that requires them to be bulky and take up all this energy, they shrink. So the key for you to understand is that your skeletal muscles are incredibly sensitive to the signals that you give them. Okay, so how do most people think about muscle? Now, I think this is kind of the way that most people consider the conversation around muscle. It is some guy in the gym chugging protein powder, lifting an incredible amount of weight, who's really preoccupied with his kind of look, with his physique. And what I would like to do is to shift the conversation away from that type of ideation and to talk about muscle as fundamental, not necessarily to how we look, meaning it's not an aesthetic or a cosmetic concern as much as it is a strength concern, as much as it is a functional health concern. Muscle health relates to longevity, to how we think, to how we feel, to our immune system, and to our metabolism. And again, some of this relates to things that you've already heard about before. And I would hazard that many of you who are tuning in either live or after the fact know many of these things, know that muscle is linked to longevity. And that may be why you're interested in this topic, because you recognize that it isn't just about getting jacked so that you can look good in a bathing suit, but rather building healthy muscle so that you can live a long time and a long and healthy life. So that's really what we're going to be focusing on today. And I do want to make one point, which is I think there is a very powerful and pervasive misconception that by doing something like lifting weights or taking some protein powder, that you're going to go from being frail and thin to really being bulky like that guy I showed you in the previous slide. The reality is that it is tough to build that type of bulk. Instead, what we're looking for here is to make incremental gains in healthy muscle. So it isn't about getting really ripped so you can lift a ton of weight. It's about improving your functional status so that you can feel better today and live a longer and healthier life tomorrow. So let's start with this topic, which is muscle health and longevity, and get into it in a little bit more nuance. As we age, as we go through our years of life, we lose muscle. And we can talk a little bit about why that might be the case. But the bottom line is that we can lose up to 1% of our muscle mass per year. And here we're really going to talk about skeletal muscle. So anytime I'm referencing muscle, we're talking about that subset of muscle, which is skeletal muscle. Why? Because that is the muscle that we have the most control over, the one that we can do the most to support its health through things like exercise, through things like proper nutrition. As we lose our muscle as we age, this actually predicts decreased longevity and functional decline, which means that the less healthy muscle we have as the years go on, the lower our predicted lifespan and the lower the quality of our years is. So this means that focusing on building healthy muscle is a strategy to live a longer life and a healthier life. Really important and a fundamental tenet to everything I'm saying here is that when we focus on building healthy muscle, it lets us live a longer, healthier life. So this isn't about looking good in the gym. This isn't about looking good at the beach. Those are fringe benefits. We're talking about quality and duration of life. And to give you some context here with some of the recent research, this is an article that came out that looked at muscle strength in midlife and people's longevity. What they found here is that people who made it past age 79 were 2.5 or 250% more likely to have a stronger grip strength. Now, I'm curious here, and if you're watching live, let me know. And if you're watching after the fact, let me know in the comments. Who here has heard of grip strength and the significance of grip strength as a marker of muscle health? It's something that I only learned about recently, but the bottom line here is that our grip strength, looks like many people have heard of this before, but how much we can basically squeeze a grip strength meter is a predictor of our overall muscle health. So what they found in this study is that people who had the strongest grip strength were 2.5 times more likely to make it past age 79. What a strong, relevant correlation between something we can do something about and our chances of surviving to a longer age. So as we mentioned, that if we lose overall muscle strength and health, it correlates with a shorter lifespan. The important point here is to say we can measure this. There are surrogates, and grip strength meter, actually have one here I could show you in a moment, is a very cheap way to get a sense as to your overall muscle health. Okay, so what does it relate to when we talk about cognition? You may have heard me talk about this before. It's actually one of the most interesting things to me, which is to understand what we can do to improve our brain health and to protect our brain health in the future. Well, it turns out that one of the most important things we can do is to exercise, but it's not just about getting on the treadmill and getting in that cardio. Muscle health correlates with cognition. So having better health of our skeletal muscle correlates with better long-term cognition. And importantly, better skeletal muscle health correlates with better mental health. Now, I don't know about you, but for me, when I look out and I see how people are thinking, both in terms of the quality of their brain function and in terms of the quality of their mental state, I feel like we could all use some better things we could do to improve those aspects of our lives. And so it just turns out here that doing things that promote good skeletal muscle health is a double benefit to both cognition and to mental health. Okay, to take this one step further, what does muscle health have to do with things like immunity and metabolism? So you may have heard this from other people. You may have even heard this from me. I did a longevity webinar with Big Bold Health. It was pretty popular. Some of the things that drive longevity, our lifespan, and maybe more importantly, our health span, are going to be our metabolic state, and our immune state, meaning that if our metabolic state is balanced, we tend to live a longer, healthier life. If our immune state is in balance, we tend to live a longer and healthier life. And when either of those systems get thrown out of whack, it messes up the whole of our health. So we need to be paying attention to metabolic state and to immune state. And as you probably know, most people today have issues with at least one aspect of metabolic and immune function. The most interesting reconceptualization of the role of muscles in terms of how it impacts our health is that they are not just structural, functional parts of our body that are important for movement, but rather that muscles produce hundreds of signals that can leave the muscle, get into the bloodstream, and influence our entire body. I'll say this one more time. Your muscles do so much more than just provide structural support. When you exercise your muscle, when you strengthen your muscle, that muscle is going to produce these molecules called myokines, and I'll talk about that more in just a moment, that can influence your body throughout the entire body, not just at the level of the muscle. Myokines are these molecules. These are tiny molecules that are produced by your muscles. When you contract your muscle, you produce myokines that leave the muscle and go throughout your body. And they signal between your muscles and your brain. They signal between your muscles and your liver. They signal your immune system. They regulate your metabolism. This is so important. That's why exercising your muscles is so big of an intervention to improve overall wellness. When we regularly engage in physical exercise, we can boost our levels of myokine production. And this may be one of the most important links between regular exercise and better overall health. We even know that recent research is showing some of these myokines may influence a number of different health issues. And again, there are hundreds of different myokines. We're just scratching the surface of what these molecules are. But as we'll talk about in a moment, they have some compelling research showing that why we need to be exercising our muscles as a key intervention for protecting our overall wellness. So let's talk about this in the context, first of all, as metabolism. The very basic idea of understanding what our muscle does for metabolism is to appreciate that one of the key disorganized parts of our metabolism relates to our blood sugar. Now, you've probably heard people talking about blood sugar. Specifically, what they're talking about is circulatory glucose or glucose in our circulatory system. What do we know about glucose in our circulatory system? We know that when glucose levels go really high, or when they go really low, or if they go very high and then very low, that this creates a number of stressors on our body and can lead to a host of negative health implications. Skeletal muscle is actually the most important way that we're able to pull glucose out of our bloodstream. And that means that when we exercise our skeletal muscle, we are able to pull more glucose out of our bloodstream and into our muscle. And by doing so, we can actually regulate overall metabolism. This does a number of things. First of all, it's going to actually enable us to decrease circulating glucose, which can be an issue for many people who have too high levels of circulating glucose. But the other thing is, it actually has benefit to our overall metabolic state, including on insulin regulation. The other thing that's interesting about this is that even when you're not exercising your muscles, if you are somebody who consistently is generally exercising your muscles, they're going to use up more energy at rest. And so let me make this point again. Obviously, when you're exercising a muscle, that muscle is using up a lot of energy in the form of ATP. That's adenosine triphosphate, and in order to create that ATP, it's going to need to pull a bunch of glucose out of your bloodstream. But if you build healthy muscle, then that muscle is going to, even if you're at rest, use up more energy in order to basically keep itself moving, keep itself healthy. So the point here is building healthy muscle is a great way to kind of use more energy during the course of your day. On the plus side, if you're somebody who is looking to actually use up more calories, that's a good thing. But over time, the reason why an exercising or a person who exercises, who no longer exercises, is going to lose that muscle is because the body recognizes that it doesn't want to be perpetually allocating calories and ATP to a tissue that isn't doing anything for the body. So just to clarify it here, building healthy skeletal muscle is a great way to use up extra energy. But if you don't consistently use those skeletal muscles, eventually the body will get wise to it and will say, hey, we don't want to be burning all this energy for these muscles that we're not using. So it will shrink your muscles. In addition to the glucose, muscle can also use fat as a fuel source. So the very basic idea here is obviously we don't want to have a huge buildup of additional fat in our bodies that we're not using. So this is a good way to liberate and use some of that fat. In addition to this, we know that muscle is the primary site, as I've already mentioned, of protein storage in our body. So in order to support healthy muscle metabolism, we need to make sure we're getting that muscle the protein that it needs. And I thought it was also interesting to note that muscle can actually regulate hormones, including insulin and including other metabolic hormones because of some of the outcomes of some of these myokines. So let's talk a little bit more about this muscle as a glucose sink. I think this is such a fun fact about muscle that is helpful to talk about when people are saying, hey, listen, I'm concerned about my blood sugar. What can I do about it? I like to say, well, obviously there's nutrition, obviously there's all these other things that you can do, but have you thought about using your muscles to suck up some of that glucose, some of that sugar from your bloodstream? Muscle can actually use up 80% of your glucose, meaning it can use up to 80% of glucose use in the bodies after you're using or eating a meal. So when you exercise, you actually increase the number of receptors on muscle that pull in sugar from your bloodstream. It's a fascinating little bit of chemistry, but basically you increase receptors. So the more you exercise your skeletal muscles, the more they actually are able to pull that sugar out of your bloodstream. Beyond this, beyond blood sugar, we know that muscles have all these other metabolic properties. As I mentioned before, they can regulate insulin. Another really important fact here is that insulin resistance, and curious here as we're going through this conversation, who here has heard of insulin resistance? Let me know in the comments, or if you're here in the chat, let me know in the chat who has heard of insulin resistance. Okay, so definitely some people have heard about it. What makes insulin resistance so interesting to people like me is that it can happen long before we have issues that can be measured with blood sugar. So insulin resistance may lead to and actually promote issues with blood sugar. Insulin resistance is basically the idea that our cells become resistant to the effects of insulin, which means that it's hard for them to pull blood sugar in because they're not listening to this signal, which is, hey, insulin says you need to pull that blood sugar in to your cell. So insulin resistance appears to happen in our muscles long before it happens throughout the body. So what that tells me is that by focusing on muscles, we may actually get upstream of a lot of the metabolic issues that occur in our bodies. Importantly, we know we can reverse muscle insulin resistance. So let's put this together. Insulin resistance is an issue for our health. Insulin resistance in our bodies happens after insulin resistance happens in our skeletal muscles. Skeletal muscle insulin resistance is something we can do something about. And we'll talk about this in the context of some of the tools regarding exercises and nutrition towards the end of this conversation. All right, so now let's talk about how muscles work on the immune system. As I mentioned, muscles produce hundreds of these molecules called myokines, and many of these myokines are actually bona fide or explicitly immune signals. Beyond the signals that are produced by our muscles, we know that immune cells can actually go into skeletal muscle. And this isn't really desirable because it's similar to what happens in fat cells, where we bring in immune cells and they actually can create some problems. But what we do know again here is that our skeletal muscle can have this very close communication with immune cells where they're living next to each other as neighbors, not necessarily getting along really well as neighbors, but where they're having these interactions all the time. However, going back to the first point, muscle also produces these signals that speak to the immune system throughout the body. One of the areas that I find absolutely fascinating is that muscle signals may be produced by muscle, get into the bloodstream, go through the blood-brain barrier, and influence the immune system, specifically these microglial cells, our brain's immune cells, and in doing so, influence things like cognition and mood. So the main point to understand here is that your muscle health is going to influence your immune health and vice versa, but we can't necessarily dissociate these two things, meaning how your muscle is functioning is going to tell us about how your immune system is functioning and vice versa. So I think what we need to do is to think about exercise beyond just this idea of getting on the treadmill, going for a walk, doing aerobic conditioning. Not to say that that doesn't matter, not to say that we don't need to be, basically using oxygen and going for these long walks. I love long walks. However, we also need to think specifically about interventions that can help to promote muscle health, which means we have to look at other forms of exercise. I, in preparation for this, did a little bit of background digging into understanding why exactly the exercise recommendations are what they are. Now, I don't know about you, but growing up, I always heard that there was one type of exercise everybody should do, and there was a reason for it. And so in my case, that was doing cardio or aerobic conditioning. And the reason for it was because of heart wellness. We heard that you should be moving your body in order to protect your heart. And I still think that's the most common way that people describe the value of exercise. But let's take a little step back in time to understand whether that's always been the case or if it's something relatively recent. So, why did we start exercising? This is such an interesting question. I feel like it's been very consistent over the last decades that everyone's talked about exercise. Yet the reality of this is that it wasn't a thing, meaning 100, 200 years ago, there weren't these big groups of joggers out there. We didn't have CrossFit. There weren't people lifting weights in their homes. These were just not things that were done. And where this all got its start in the United States is after World War II, where researchers, scientists started seeing that people who regularly moved their bodies tended to have better cardiovascular health. And so they started to log basically people's exercise reports. And what they found here is that people who were regularly engaging in rhythmic exercise, interesting, right? The way they frame this. But what they're really talking about here is aerobic conditioning. So if you're jogging, that's a rhythmic exercise. It's something that you kind of just repeat time and time again, gets your heart rate up. What they found here is that when they looked at these journals, these logs of people who were reporting on their exercises, the more they did this rhythmic activity, the better their overall health was. So they started with the heart, and then they kind of expanded this out. And they said, well, look, we know that aerobic conditioning seems to work well for protecting the heart. What does it do for general health? What does it do for immune health? What does it do for longevity? And what they found is that, hey, it looks like aerobic conditioning is associated with benefits across all of these different domains of health. But now what we know, and this is, again, shockingly, only something that has been recently kind of investigated in the scientific literature, is that there are different types of exercise and there are different mechanisms behind these different types of exercise, and there are different values to our health from different types of exercise. So there are many different types of exercise. For the purposes of this conversation, I'm going to focus on two. The first one is aerobic exercise. And really what this means, if you break down the meaning of aerobic, is using oxygen. So the point of aerobic exercise is to improve your cardiovascular endurance, to improve your stamina by using oxygen to generate energy. And so what this means at the level of your muscle tissue is that your muscles should be primarily using oxygen to break down carbohydrates and fats to create sustained energy. So if you think about going for an hour-long run, you need to find a way to access fuel that will sustain you for a long period of time. That's very different from, let's say, a sprint. Very few people can maintain a sprint pace, kind of by definition, for more than, let's say, 100 yards or 100 meters. So here again, we're talking about using oxygen. And so this is something that is moderate intensity, longer duration exercise. These are things that allow us to go for longer distances. And if you think of our hunter-gatherers, this is going for miles and miles of walks or runs. This is aerobic exercise. But the other major group of exercises are anaerobic exercise, again, without oxygen, anaerobic. So the focus here is on building muscle strength, to build power, to build speed by using stored energy sources and not relying on oxygen. So instead of using oxygen to break down carbs and fats, what we're talking about here is using stored energy in the form of glucose or glycogen for these short bursts of high intensity effort. So instead of talking about kind of moderate intensity, long duration, we're talking about high intensity, short duration bursts of exercise. When it comes to muscle health, both aerobic and anaerobic exercise appears to benefit our muscle health. And if we're going to talk about just kind of at a high level, we could talk about some of these things in a little bit more detail if people are interested. But again, there's a lot of nuance, and I want to just break down what I understand to be kind of the top line, most important things to consider around each of these forms of exercise for your health, and specifically, what you can do to make this practical today. Before I get to this next slide, what I would like to say is there's no one size fits all. And many of you out there might be saying, oh, well, I have this issue, so I can't do that thing. My belief is that any exercise that you can do is going to be better than not exercising at all. And so if what you can do right now is basically get yourself up out of a chair and go for a little bit of a walk, that is the best exercise for you. What I'll be reporting on, though, is what the literature tells us, what the scientific literature tells us would be maybe closer to optimal. So if you're out there and you're not exercising at all, the best exercise is the one that you're going to get yourself to do. However, if you're already out there and you're exercising, you're saying, how do I optimize my routine? Some of these tips will be what's relevant to you. So aerobic exercises, again, you're thinking rhythmic exercises, things that are more like cardio that you can do for longer forms, longer amounts of time. Key tenets here, key takeaways, find things that you like. If you don't like your exercise, you're not going to stick to your exercise. This is no mind-blowing bit of information. But something that doctors like me tend to do is say, you need to go and do 30 minutes of exercise 5 days a week, and jogging is a good fit. For some people, they hate jogging, so that is a completely unreasonable way to look at this. Consider finding things that you enjoy. That can be going on a walk with your friends. That could be swimming. That could be rollerblading. It doesn't really matter as much if your goal is to go from not using any sort of aerobic conditioning to some. So I think this is where bringing in friends, considering sports, considering group activities can be very helpful. If you want to think about what is the optimal range based on the research, it's around 20 to 30 minutes of moderate intensity exercise in terms of the maximum value with the shortest amount of time. What you should consider here is, are you breaking a sweat? Are you raising your heart rate? There are considerations around what level of heart rate, 70 to 80% of your max and VO2 max. What I would say here is some of the surrogates would be, are you breaking a sweat? And do you feel like your heart rate is going up? Um, if you don't do a lot of aerobic exercise, then something like high intensity interval training, which is a little bit in between aerobic and resistance, may not be a good place to start. However, there are some data, and I just wrote a blog on this on my website. If you're curious, that'll be on the best exercises for brain health, suggesting that high intensity interval training may have some additional benefits beyond what aerobic conditioning provides. But that's aerobic conditioning in a nutshell. Again, find something that's sustainable that you can enjoy, something that you can kind of break a sweat, but not necessarily something that you're going to be so out of breath that you can't even speak. The other component of this is the anaerobic or resistance exercises. There are many considerations around how to do this right. But if you want the biggest bang for your buck, realize that the largest muscles in your body are in your legs. So if you're trying to maximize value, decrease the total amount of time you need to spend, you want to think about targeting your large muscle groups. And beyond that, you want to think about compound exercises that involve multiple muscle groups. So the difference here being, if you do something like a bicep curl, you're really only hitting that one muscle on that one arm. That is not a compound exercise. If you do a pull-up, now you're engaging multiple muscles across your body. So think about what you can do that engages multiple muscles, and if it requires a little bit of balance, that's even better. Ideally, I think you're shooting for 2 to 3 days per week of doing resistance training exercises. And what I would say is, if you don't do this, if you haven't done weightlifting before, you don't need to start with heavy weights. You can start with body weight. You can start with bands. These are all wonderful opportunities. And I would highly recommend, if you don't know your way around a gym, don't just jump in. If you injure yourself, you're not going to be able to maintain that routine. So I would recommend seeking assistance, either from somebody who knows their way around the gym. That could be a friend, that could be a family member, or a personal trainer, to make sure that you're actually working on your form. Form is so important here because beyond just the benefits you're getting to your muscles, you want to think about trying to balance things out across your body so that it translates into function. If you go to the gym and you only exercise, let's say, the front of your body, you're just doing tons of bench press and you're not focusing on your back muscles, you have a much higher chance of not only injuring yourself, but also not being as functional in your day-to-day function. I had this happen actually recently because I was doing a lot of kind of overhead for pickleball, but I wasn't strengthening my back muscles and therefore it was out of balance. So I worked with a personal trainer, or sorry, a physical therapist to start to target some of those posterior muscles so that things would be more functional so I could go back to playing pickleball, which is, as we all know, is the only objective in life. Okay, so this is exercise. A lot more I could say about this. And again, if you're curious about some more specifics, I have a blog on my website, austinperlmutter.com, and you can read about high intensity interval training, mind body training, and some of these other variants. But here are the basics in terms of aerobic versus resistance. Let's move on to, I think, what is a very interesting topic to many people, myself included. And we're talking here about nutrition. I would be very curious as we're getting into this, for those who are tuning in live, what is the most important thing that you think is relevant in terms of nutrition for muscle health? And if you're watching this after the fact and you would like to comment, tell me what you think at this point in the lecture is the most important variable as it relates to nutrition for muscles. Some of the answers I'm seeing here are protein and amino acids, adequate protein, adequate calories, balanced diet with protein, protein, low glycemic, protein and carbs. Fantastic. So what do your muscles need? I did kind of give you the tips here in terms of saying your muscles contain most of your body's this, and the answer is protein. Beyond protein, amino acids. So protein is really just chains of amino acids that are linked together. You probably already knew all of this, but if we're going to talk about beyond just protein, what are some of the other studied interventions to promote healthy muscle? How about creatine? What about even omega-3 fatty acids? You probably heard about these things before, but we're going to dive into some of what we know around the value of supplementation for muscle health. Okay, protein. I have experienced, and probably all of you have as well, a whole lot of conflicting information around what you should be doing for protein. Whether it's this is the form of protein, so it has to be animal based, or you need this many grams a day, or you have to be supplementing with this many amino acids. I think it's very confusing. And I'm also a proponent of this belief system, which is when things are too confusing, people don't know what to do, and so they do nothing. So what I'll try to do here is to break this down based on what I have seen in the scientific literature, with the caveat being that, like any aspect of nutrition, in a perfect world, you're actually working on what is unique to you. Everyone's protein needs are not the same. Not everyone is going to respond well to protein. Some people do great with whey protein. Other people have issues with whey protein. Just to give you one kind of correlate to this, an interesting aspect of whey protein, milk-based proteins, is that it activates a pathway called insulin-like growth factor 1, IGF-1. Now, that's good on the one hand because that is an anabolic, it's a building pathway. But some people can actually get too much activation of IGF-1 in their skin, which is correlated with the development of skin issues. Not everyone, but for some people who are predisposed to this, they may not want to take massive quantities of whey protein because it can activate that IGF-1 pathway. Most people seem to do just fine with it. But just to give you an example here, it's not a one size fits all. With that said, let me talk about some of what I have seen and what seems to be pretty well established in the medical literature. So animal protein, we'll start with this first. These are things that are relatively objective. Animal protein, and we're talking here really about food-based sources, tends to be more digestible, tends to be more balanced, tends to have more accessible essential amino acids. It has more of key amino acids for muscle building, like leucine. It's more anabolic, meaning it tells our body to build more than does plant-based protein. When we look at individual protein isolates, the most popular animal-based protein sources will be whey protein, casein, and collagen. So these are just some ideas. This is not me telling you to eat animal protein. We'll talk more about some of the nuance around this. But here's some of the things that we know. And I guess just to kind of put a point on this, this means that if you were going to eat a 10-ounce portion of steak as opposed to a 10-ounce portion of black beans, the steak is going to have, by weight, more protein, and it may be more available protein. This does not mean that there isn't good protein in black beans. And beyond this, it does not mean that you need to eat animal protein to get to adequate protein levels per day. Plant-based protein sources, as it relates to isolates, so protein powders, soy, pea, and rice protein are the most common sources. As it relates to dietary quality, and I'm sure that many of you have heard this before, because the distribution of essential amino acids in plant-based protein tends to be a little bit more biased towards specific essential amino acids, you can potentially need to combine multiple plant-based protein sources in order to cover your bases. Now, again, you've probably heard this before, but it just reiterates this idea, which is if your goal is just to get the most accessible protein in a food, animal-based protein sources are just far more concentrated in terms of the amino acid profile of the essential amino acids. And that's not necessarily the most important consideration for everyone. As we'll talk about in a moment, when we look at our goals in terms of protein needs per day, you can absolutely meet this without having to go into the animal-based protein sources. There's also mixes of proteins, right? So many people, most people, don't just eat a vegan diet or a carnivore diet. And so when you're eating plant-based sources of protein and animal-based protein sources, you're actually getting a combination of all these amino acid profiles. And in many cases now, we also have mixes of proteins, isolates that contain some animal and some plant-based protein sources. So These are, again, the very basics. I'm sure that many of you out there who are tuning in live and who are watching after the fact have a lot of questions around this. How much leucine should I consume? What are the essential amino acids beyond that that I should be concerned about? What about this one protein powder that may have this breakdown of amino acids? We're talking here about some of the basics, and I will make this point again. This is not to say that there is a one size fits all. Some people, myself included, enjoy certain types of proteins and don't do well with other forms of proteins. So I shouldn't generalize and say that just because I don't tolerate something, that's necessarily a bad thing for others. And similarly, I shouldn't say that just because something goes really well for me, that that's necessarily a good thing for others. All right, let's talk about amino acids. As I mentioned, amino acids are the basically building blocks of proteins. And so the essential amino acids, these are especially the branched chain amino acids, or BCAAs, as you may have heard them described before, are probably the most powerful amino acids to stimulate muscle growth after resistance training. So it's like valine, amino acids like valine and leucine and isoleucine. If you are a chemistry nerd, you can look up the structures of these molecules online and you will see why they're called branched chain amino acids. But these are molecules, these are amino acids that seem to have the most potent effect on stimulating muscle recovery after resistance training. There's some really interesting research being published currently on leucine, and it may be the most important of these branched chain amino acids as it relates to basically being anabolic, telling the body to build. Beyond this, there's some data points showing that taking standalone amino acid supplements may be good for the building of muscle. However, I would say that data is not as good as what we know about just good overall nutrition, nor is it as good as the data for resistance training. So here's kind of what I compiled in terms of reviewing a bunch of studies as it relates to just taking a standalone amino acid, which is a question I often get for building healthy muscle. So some of the studies, here's a couple of quotes that I'm going to explain. So the first one being, a growing body of literature emphasizes that branched chain amino acid supplementation alone does not enhance muscle protein synthesis any more than consumption of complete high-quality protein containing the full range of essential amino acids. Another review paper found that branched chain amino acid supplementation does not appear to have a significant impact on muscle performance. And then another review paper said, with regard to nutritional intakes, total protein intake per day rather than protein timing or quality appears to be more of a factor on this effect during long-term exercise interventions. I'll talk about that last one in just a moment. But as it relates to essential amino acid supplementation, I think the overall body of research suggests that at an individual study level, there may be a benefit. At a more macro perspective level, it seems like you're better served focusing on overall nutrition and exercise than worrying too much about getting the right levels of the right amino acids. Okay, what about just protein? Now, this was really interesting. Again, in preparation for this presentation, I was asking this question about what do we really know? Like, let's forget about what we see online and the influencers saying you've got to eat this many grams of protein at this time of day, otherwise don't even try. What do we actually know when we look at these large-scale analyses as it relates to supplementing with protein in terms of what it does for our muscles? So based on the results of these two papers, here's what they said. Protein intake appears to provide modest benefits to athletes in improving their performance, particularly in enhancing endurance. Subgroup analysis suggests that protein intake improves muscle glycogen levels, and the co-ingestion of protein with carbohydrates is more effective for endurance athletes than high protein intake alone. So I thought that was interesting. Number one, it said that basically taking protein seems to improve, in this case, endurance, but basically muscle health, and that taking protein with carbohydrates seems even better. The additional paper here said, the evidence in this meta-analysis supports the hypothesis that additional protein ingestion, 1.6 grams of protein per kilogram per day or higher, leads to small increments in lean body muscle mass in studies enrolling young subjects in resistance training. So basically what we're saying here across these two is that supplementing with protein does seem to help, but it does seem to be the case that these benefits are not tremendous. It's not as though simply taking protein powder is going to make you a championship athlete, nor is it the case that simply taking protein powder is going to cause you to generate huge muscles. What you need to do is combine it with especially resistance training in order to get the benefits of that protein supplementation. Here are another couple of studies, this one looking at sources of protein. So again, plant versus animal, what are the values for older adults? And the second paper, the anabolic properties of plant versus animal-based protein sources in supporting muscle mass maintenance, a review paper. So the first paper, they said that they need to do another study to look at the results between animal versus plant proteins on muscle outcomes among people who are not consuming the right amount of protein to assess whether protein source is magnified at lower dietary protein compared to populations with a higher total dietary protein. Basically saying here that they still needed to determine whether animal versus plant really made much of a difference. The second quote here, high quality protein consumption optimizes protein metabolism at both the whole body and skeletal muscle level, especially in older people. Plant-based protein sources that are rich in fiber and micronutrients may be valuable, but have lower anabolic potential than animal-based proteins. Strategies to improve these properties may include fortifying plant-based proteins with specific amino acids, mixing several plant proteins, and mixing plant with animal-based protein sources. What do you take from all of that? Well, what I take from all of that is it does seem to be the case mechanistically, meaning when you look at a cell study, that an animal-based protein source is more potent at growing muscle than a plant-based protein source. But when you look at these large-scale analyses, it doesn't seem to be as significant, meaning if you do choose to be vegan or if you choose to be optimizing towards plant-based protein, that seems like it is still a completely reasonable strategy to build and sustain healthy muscle. As we will talk about in a moment, though, you still need to be conscious of reaching your overall thresholds in terms of getting adequate protein per day. Okay, so let's talk a little bit here about that last study talking about how protein plus fiber plus polyphenols may have outsized benefit. One of the things that seems very clear from nutritional research is that the more we try to strip things down to an individual nutrient, the more data and signal we may lose. It would be nice to say that we could basically solve for all of our health issues by just doing a detailed analysis of an individual food, finding one specific molecule in it, and then taking a whole bunch of that molecule. It's going to fix our problems. But the reality is that humans have basically for millennia been consuming real food, not protein powder, not individual nutrients. And so our bodies have responded to that in a number of ways. One of the ways that this has happened is through the human microbiome. So some of the important data here is that what happens in the microbiome influences metabolism, influences immunity. As we've already discussed, we know that our muscle is both responsive to and influences metabolism and immunity. So if I was going to put this into a more kind of definitive, concrete perspective, it is to say that as much as it would be nice to say, here's the type of protein powder you need to consume to solve for your issues, the reality is that humans are complex systems, and the closer we can get to actually eating real food is probably going to be best for our overall wellness. Okay, so let's consolidate all of this into some ideas here. One, adequate protein to support muscle health is important. So people who do not consume enough protein are at a, unsurprisingly, much higher risk of having muscle issues. What is adequate protein to support muscle health? I will preface what I'm about to say by knowing that you're going to go out and hear some influencer or scientist or somebody else disagree. They're going to say, this is the absolute answer. And what I can tell you is that after a review of the literature, here is what we seem to know. We need to be consuming a minimum of 0.8 grams of protein per kilogram of body weight for the average adult. That converts to about 0.36 grams per pound. Let me emphasize this point again. This is the minimum amount of protein that we need to consume each day in order to maintain basic muscle. Where do we get it from? Animal-based sources, plant-based sources. I think there's some data suggesting we should be consuming it from both. Why? Because that is historically what humans have done. For certain populations, and for one reason or another, I think most people kind of should fall into these populations, but for older adults, for a number of reasons, but remember, we tend to lose muscle as we get older. So if you're over the age of 60 to 65, if you're a more active person, or if you are trying to build muscle, then you want to consider going closer to 1.2 to 2 grams of protein per kilogram. On the upper end of that spectrum, you basically get to 1 gram of protein per pound of body weight. That is a lot of protein. And what I do think here is the case is, while it's easy to just keep pushing things further and further and saying, hey, just keep eating protein, only eat protein, there are downsides to only consuming protein. part of this comes from the fact that protein is incredibly anabolic, but also protein in high levels may not be all that great for the immune system unless we're actually using that protein for a purpose. So to consolidate this again, I think that the baseline is close to 0.8 grams of protein per kilogram, or roughly 0.36 grams per pound. For those who are trying to build muscle, who are a little bit older, or who are more active, ideally this is most people. Again, I think you start moving that up. So all the way up to around 2 grams per kilogram at the higher level. As I've said before, though, it is tough to make generalized nutritional ideas relevant because each of you who are out there listening are going to have opinions on what is best for you. So if you are somebody who is already doing a ton of exercise, a ton of muscle work, and you need to really be bulking up your muscles, yeah, you're probably going to be at the higher end of that spectrum. If you're somebody who has really not done much exercise at all, or maybe somebody who has issues with protein powders, you should be considering differential strategies. And again, in a perfect world, or my recommendation would be seek out a person's advice who is a healthcare practitioner who can guide you towards what is going to be best for you. Okay, so what does all of this mean? I think one, protein supplementation by itself is not nearly as helpful as protein supplementation plus resistance training. There's no way around this. If you want to build healthy muscle, you need to tell your muscles that you need them, right? You need to give your body the signal that it is important for your body to put on healthy muscle. Protein can help to maintain healthy muscle, and in some studies, it has been shown that simply supplementing with protein can build a bit of healthy muscle. But if your goal, and it should be, is to build healthy, sustainable skeletal muscle, you need to do the exercises to tell your body to build and sustain that muscle. So protein supplementation plus resistance training, I think, is really where we should all be focusing our time. Okay, I'm going to talk here a little bit about a couple of supplements, one being creatine. I'm curious here, who has heard of creatine supplementation for muscle health? And if so, what form of creatine have you heard? Drop it in the comments here, put it afterwards if you're watching this on YouTube. I did do a video on creatine. It became very popular, specifically talking about the role of creatine for brain health. What is creatine? Creatine is an amino acid. It's made in our bodies. It's found in our diet. And it's stored in our cells in two forms, either free creatine or phosphocreatine. What does creatine do? Well, really interesting. Creatine helps us to regenerate a molecule called adenosine triphosphate, our core energy block for our bodies, for our brains. It actually transfers a phosphate group to ADP to create ATP. We know from the data that there's value in creatine for improving muscle strength in older adults. We also know, interestingly enough, that creatine may boost brain function. I'll say the typical caveats here. This is not medical advice. This is not telling you to do this. This is simply talking about what the research is telling us. But what the research is telling us is that at a dose of 3 to 5 grams per day, so it's higher than the milligram doses we get with other supplements, that creatine, specifically creatine monohydrate, may be valuable for building and maintaining healthy muscles, for supporting brain health, for improving athletic performance. Again, with the caveat being some people do experience side effects. You should work with your healthcare practitioner. This is not medical advice. Okay, what about omega-3 fatty acids? So this is one that I've only recently been learning about. So omega-3 fatty acids, I'm sure you've all heard of before. These are a type of polyunsaturated fatty acids. They are found in plant and animal-based food, but they're really found in higher concentrations in marine-based food, specifically fatty fish. And really the ones that are most interesting are EPA, eicosapentaenoic acid, and DHA, docosahexaenoic acid. So omega-3s we've historically thought of as important for our heart, as important for our immune system. But recent data suggests that omega-3 supplementation may support lower body strength and may actually improve muscle and overall functionality in older adults, even if they're not growing their muscles, which I thought was so interesting. Because here again, let's go back to this point that I made before, which is that muscle health is not just about the bulk of the muscle. It's about the immune system. It's about metabolism. Are those immune cells getting into your muscle and messing with its health? Is that muscle developing insulin resistance? It may be the case that omegas are more meaningful to muscle health, not because they're going to build bulk, but because they're going to balance out metabolic and immune state within muscles. So this is a really interesting little bit of literature that I thought you'd be curious to hear about, but omega-3 fatty acids and creatine monohydrate are emerging as two considerations around things we could consider to support healthy muscles. All right, let's put it together. Healthy muscle is a tool for promoting longevity through metabolic and immune pathways. We, as humans, tend to lose healthy muscle as we age, but paying attention to this, what are we telling our bodies we need? Our bodies are smart. If we're telling our bodies we don't need that muscle because we're sitting around, we're not lifting heavy things, we're frail, it's going to say, okay, fine. We're not going to dedicate energy to that muscle. But if we take steps to promote and to build healthy muscle, then we can help to offset that age-related muscle loss. What are the best tools to do this? It's a combination of nutrition and exercise strategies. Resistance training, weight training, and aerobic conditioning. This is probably the best overall combination for muscle health. It's not one or the other. Most people tend to prioritize aerobic conditioning. That message has been drilled into our heads over the decades. You've got to get out, you've got to jog, you got to get your heart rate up. True, and we need to do resistance training, weight training. It doesn't have to be an insane amount of weight. You don't have to get into the squat rack or the bench press on day one. You just have to find a way to teach your muscles that you need them. You need them to be strong. You need them to be functional. That can be body weight exercise. That can be bands. There are so many ways that we can teach our muscles using resistance training to build up their strength. Protein intake, as I mentioned before, somewhere between 0.8 to 2 grams per kilogram is usually the optimal range. And you really do want to think about trying to work with a practitioner or at least a health professional to help guide your protein and supplementation towards what is best for your unique body. Okay, so we've covered a lot of ground here. I'm so grateful to all of you. It seems like we've had some really great turnout here in the comments and in the engagement in terms of this conversation. I want to provide you with a couple of resources. So the first one is follow social media, the Big Bold Health social media, and my social media account. Lots more information around these topics. Big Bold Health, wonderful for the immune system. Dr. Austin Perlmutter, which is my social media, lots more around specifically brain and muscle health. And if you're curious to learn more, again, I did a recent full-length podcast on my YouTube channel, Dr. Austin Perlmutter, where I dive into the mechanisms around brain health and how that relates to muscle health. So you can get lots more resources there.